Hello. In this video, I will show you how to configure standard ML drive to work as DC-DC converter with EtherCAT CoE as master communication interface. When using drive with EtherCAT CoE, it is highly recommended to use control section of ML drive equipped with EP option, and this is additional port X26 called engineering port. And we use this port to communicate with our laptop. To configure our drive, we use latest version of Bosch Rexroth IndraWorks Ds software. Our software will right away find our drive with new firmware. First window that shows up is power supply status. And diagnostics from drive shows up by default in German. So at first, we'll change parameter S-0-0265 from value 0 to 1, and that will set our language for diagnostics to English. Next, we go to basic configuration screen, and here we can see our new firmware and active configuration as a supply unit in operation mode mains operation. To configure DC-DC converter mode, first we must activate a DC extension package, DCE. For this extension to be activated, drive must be rebooted. After rebooting, we open configuration screen again, and with DC extension active, we can edit operating mode and select DC-DC converter. And again, to activate this mode, we must reboot our drive. Next, we can check our active master communication and change it here from default circles to CAN application protocol over EtherCAT CoE. And again, to activate it, we must reboot the drive. Back after reboot, we can see master communication in initial mode, but when we try to switch drive to operation, we get this error. And that means that there are some invalid parameters, and list of them is stored in parameter S-0-0423. So let's look into this parameter. First, please note that with CAN protocol active, most drive parameters have two identifications. One is Circos SNP parameter ident, and second is CAN open hex-coded ident. Going back to our invalid parameters list, we can see that there is a lot of them. But do not worry, this is typical. Every time we change a major communication or operation modes, some dedicated parameters are deactivated and new are added. There is a special editor to help with this situation, and it's called IDN list of invalid operation data. Here we can see those invalid parameters, and most of them are parameters for newly activated EtherCAT and DC-DC converter. Here we can reset them all to valid data status. Now we try to switch to operating mode again, and we can see that now only 4 parameters are showing as invalid. Sometimes parameters are invalid because they are out of allowed range, so we can use load basic parameters function to reset them. Please note that after basic parameter load, our language is set back to German. So first, we change it to English. Also, our operating mode was set to mains operation. So we set it back to DC-DC converter and then reboot. First, we'll try to switch to operating mode. Then we check our parameter S-0-0423 and see remaining invalid parameters. Now we take IDN of our invalid parameter and paste it into IDN window to edit this parameter. So this is switching frequency, and for standard power supply is set to 4.2 kHz, but for DC-DC converter it should be set to 6 kHz. We try operating mode again, and this time our invalid parameter is S-0-1709.0.1 and it is primary operation mode. We can open editor for all operation modes, and right away we can see that not all operating modes available for power supply are supported in DC-DC controller. So for primary mode, we select voltage control, and please notice that for DC-DC converter it is a special value 8203. Then for secondary operation mode 1, we select current control. For secondary operation mode 2, we select voltage control. And for secondary operation mode 3, we select current control. Now we can switch our drive to operating mode without any errors, and that means all parameters are valid. But still, when we check diagnostic status screen, we can see that our drive system is not ready for operation. So we check help file for error E2810, and looks like we have a problem with ready signal from additional devices on our IndraBus network. IndraBus cables should be connected at front of the drive to ports XG1A and XG1B. We are working with single drive, so we are not using IndraBus, but still those two ports need to be properly terminated with special plugs type RPS0025. So we can see our drive ready in operating mode, and when we check EtherCAT status, this field bus is in Init stage, and in data channel, both real-time inputs, axis telegram, and real-time outputs, master data telegram, are ready to be configured. Further configuration of our system will be done by Rexroth IndraControl XM2x running as EtherCAT CoE Master. To avoid further conflict of IP addresses with our master control, we change IP address of our drive to 192.168.1.10 and then restart. Our XM2x control was reset to factory default initial mode with default IP address 192.168.1.1, and will connect to our engineering laptop using port XF5. We'll configure this control using latest version of IndraWorks engineering software. So first, we'll create new empty project and then drag and drop into it our IndraControl XM type 2. First, we can give our control a name or keep default name IndraMotion MLC1. Next, we must select an IP address of our control. And please note that when we select address of our control and it is connected to the network, system will detect it. A new link to IndraControl First Touch shows up. After we click on this link, our default web browser opens up and we can sign in into our control. A default username is Bosch Rexroth and default password is also Bosch Rexroth. When we go to firmware management, we can see that there is no active system firmware and our control is in initial mode. So we'll go to Restore System tab and here we can select our firmware file. And then to initialize upload, we click Restore. That will take a couple minutes. Then after upload, system will restore this file automatically. Last step we'll do here in First Touch page is issue a command to reboot into system mode. Going back to IndraWorks Engineering, we can execute connection test and our control will answer back. In step 3 of our control insert, we leave all default settings. And in step 4, we must make sure that EtherCAT Master functional package is activated. Here we can also deactivate all other packages, leaving only the default package, Programmable Logic Control. In step 5, we verify our configuration, and then system will add this control to our project. When we open our control, we can see EtherCAT Master configurator already prepared for us. For EtherCAT Master to communicate with slave device, it must have installed a special ESI description file for this device. This file is provided by slave device manufacturer. So in our case, this ESI file for HMU PSB drive is available on boschrexroth.com webpage. Here we go to local side of USA, then electric drives and controls, then servo drives online catalog. Here we go to control units and select first of them. Then we go to downloads and here we can scroll down to find our file and then download it. This is a zipped file, so first thing we need to do after download is to extract our configuration files. After extraction, we can look into new directory and see our ESI file with all supporting files. Going back to IndraWorks Engineering, and here we'll add new ESI file to our project. So first we go to Tools, then Device Database, then Add Devices, select our ESI file, and see System adding it to the list. We can verify it by checking our library. So first we go to Periphery, then EtherCAT, and then scroll down to our device, IndraDrive PSB 20x21 CoE. When we click on it, we can see more information about this device. Please note that there is a very detailed help file built in our system. So we can click on Help tab, then wait a couple seconds, and then type in index window our keyword to find, for example, EtherCAT. And right away, we can see a list of topics related to EtherCAT. So here, under Configuration Overview, and then Cabling, we can check how to connect our control to slave drive. And we can see that in our case, with XM2x we must use port XF1. When we look into topic EtherCAT Master event for externally triggered PLC task, we can see that for proper synchronization of our PLC with EtherCAT cycle, we need to create task controlled by event _op_mode EtherCAT cyclic. So in order to do it, we'll go back to our project, then Logic, and here we can see a tab, Task Configuration. Inside there is one default task pre-configured for us already. It is a cyclic task running every 10 milliseconds with priority 5 and calling program PLC prog. Now we'll add our new task and name it Task EtherCAT. Then we edit it, set priority to 3, which is higher priority than priority 5, then set type to external and controlled by EtherCAT cyclic event. Next, we'll create new program dedicated for our EtherCAT operation and name it PR EtherCAT. We want this program to run synchronously with EtherCAT clock, so we'll call it from our new task EtherCAT. For those changes to take effect, we need to compile and download our project. So first we build, and then debug and login. After download, we need to start our program, and then when we click on Task Configuration, we can live monitor both of our tasks. Now we'll focus on our EtherCAT Master. First, we run built-in EtherCAT bus scanner. And right away, system finds our IndraDrive ML DC-DC converter running PSB firmware. We can apply this device directly to our project, but first we must log out. So after logout, we run scan bus again. And this time we can use button insert all newly scanned devices and put our drive into project. When we click on our newly added device, configuration window opens up with default data for communication, process data, startup parameters, and so on. We'll keep majority of them in default values, but we need to change some of them. In order to do that, we need to enable expert settings. After that, new tab Expert Process Data shows up, and inside we can configure EtherCAT Process Data Objects (PDO) for our drive. So first we'll work on outgoing signals from our control, and those will be PDOs received on the slave side, called also master data telegram. After we click on Insert, a list of most commonly used parameters shows up, and first we'll select parameter Power Supply Control Word. Please note that for this parameter and most of others, we need to select subindex 1. Our attributes for this parameter are taken from ESI file that we installed. And system automatically sets for us name, index, bit length, and data type. System also automatically updates size of our outputs. Second parameter that we'll add to our master data telegram is DC voltage command value, and third is DC current command value. Next, we'll work on PDOs transmitted from our drive called axis telegram. And first parameter we'll add is power supply status word. Second is actual DC bus voltage. And third is DC current feedback value. In order for those parameters to take effect, we need to compile and download our PLC program. So we build our program, but for download, we call back our IndraDrive DS software and check our drive. And we remember that in our communication settings windows, lists for both transmit and for receive parameters are empty. So now we'll initialize PLC download and at the same time watch settings for drive communication. We can see that after finishing a download, system automatically wrote our communication lists into the drive. When we click on Active Process Data, we can see that list in a drive match list configure in Process Data. When we switch to EtherCAT Master tab, we can check Past Diagnostics and see Master and Slave Status, Operation, OP. On the drive side, we also see Field Bus Status, Operational. Going back to our IndraDrive configurator, we'll open EtherCAT IO Mapping tab. Here we can see our parameters mapped into PLC variables. By default, those variables here are updated only when used in a logic. To monitor variables all the time, we need to change configuration of variable update to enabled 1 or enabled 2. After compile and download, we can see our variables live. So let's verify this. We'll look inside our drive, then look into parameters, and then into parameter actual DC bus voltage. We can see matching values. The same with parameter DC current feedback value. For parameter DC current command value, we'll go opposite direction and force new value from PLC side. So first, we prepare new value for this parameter. We can see in the drive still old value. Then we write it into parameter. And right away, we can see new value in the drive with proper scaling. Now we'll go back to our expert process data editor and add some new parameters. First, we'll go to AT configurator and add here parameter 3506 PLC global register A16. Next, we'll go to master data telegram configurator, and here we have the same list of registers from A16 to A32. What if I want to use a register A00 or another parameter not showing on the list? So now I will show you how to add such a parameter. First, we'll go back to our drive and run parameters search. New window opens up. We can open a list of all operation data and then scroll down to our parameter PLC global register A0. After we click on it, editor shows up. Here you can see IDN for this parameter, and it has EtherCAT index number 34F6 with subindex 1. Now we can go back to our MTD editor and add new parameter. So we add our name, then index and subindex, and then data type. For this new list to take effect, we need to compile and download our project. But before doing it, please be aware that those PLC registers and internal PLC in a drive can be used only when functional package MLD is activated. So let's go to our drive, then commissioning, and then basic configuration, functional packages. Here please make sure that additive functional package IndraMotion MLD is activated. Now we'll show again PDO settings in our drive and download our project. After download, we can immediately see our AT and MDT list updated. And when we go to EtherCAT IO mapping, we can see registers added to our list and active. So let's test it. First, we'll prepare value 55 for register A0 on a PLC side. Then look into the same register on drive side. Then write value. And right away, we can see new value in the drive. While still in the drive parameter editor, we will look into PLC global register A16. And now from the drive side, I'll write into this parameter value 66. And right away, this value is transferred into control side. Next, I will show you how to use those registers to transfer data from our XM2x control to any other drive parameter. We'll use for that IndraMotion MLD functional package, which allows us to create a small PLC program inside the drive. To do that, we'll use IndraWorks engineering software again, and we'll run it with new MLD project parallel to our XM2x project. So we start second instance of our software and create the new project, MLD for PSB. We open our new project and then use built-in function to scan for devices. New window opens up, and here we can select to search Ethernet for IndraDrive. Next, we can select what network to search. Our drive should show up on the list, and when we finish, drive will be applied to our project. When we look inside, we can see the same screens we used to see with IndraDrive Ds software. For example, our PDO configuration lists. And additionally, we'll have new tab MLD. Inside this tab, when we click on Logic, system will open for us a window where we can select what type of PLC application we want to create. We will leave it at default settings, standard project with empty program. It will take a couple seconds for logic to be created. And then, the same like with XM2x logic, we'll create our new program, name it PR EtherCAT, and select ladder logic diagram as implementation language. This program will run in default cyclic PLC task. So first we'll open Logic Editor for our new program and start first rung with empty box. This box will be used to transfer data from our PLC register into internal parameter. And to do that, we'll select the type move for our box. Now we can start typing names of our variables. But before doing it, to make our work much easier, let's make sure that smart coding function is activated. So we go to Tools, then Options, then IndraLogic 2G, and then Smart Coding. And here we select to list components after typing. Back in our logic, as soon as we start typing our global variable name, system shows us the list, and we can select MX base. Then we click on dot and new list shows up. Now we select DV axis, and it is direct variable structure for all local axes. Then we select the structure to be for axis 1, and then a list of all available parameters shows up. Now we can scroll down and look for parameter P_0_1270, and it is our PLC register 0. So this is a parameter we read from. We can copy this variable and paste it on outside of our box. Then activate Smart Coding again, see a list, and select a parameter we want to write into. And for example, it will be a parameter S_01706_0_160 reactive power command value. Next, we'll compile and download our program into the drive. Then right away we can see our PLC register showing the value sent from XM2x control. And after starting a program, we can see data transfer to our reactive power command. We can verify this parameter from drive side and see value transferred. We'll do it again, this time directly from XM2x project. So we prepare a new value. Then, while monitoring our parameter in a drive, write new value on XM2x side and see it transferred. For our last exercise, first we'll go back to our MLD drive logic and add second rung. In this rung, we will transfer data from parameter reactive power command value into parameter PLC register A16. After download, we can see logic in a drive running. So in the next step, we'll switch to our logic in XM2x control and write a new value to our outgoing PLC global register A0. We can see right away that our system works as intended and data was transferred to the drive and then back to control. This exercise concludes our video. Thank you for your attention.